Hi, welcome to this lecture, Hexadecimal number to decimal number conversion in section 4. In this lecture, we will study how to convert hexadecimal numbers to their decimal equivalent. But before we do that, you may want to remember a few powers of 16, which will help you to do the calculations quickly. For example, we have 16 raised to 0 is 1, 16 raised to 1 is 16, 16 square is 256, etc. And even if you remember up to 16 raised to 4, that is 65536, this should help. In the similar way, we have the fractional values. 1 upon 16 is 0.0625, 1 upon 16 square is 0.0039, and 1 upon 16 cube is 0.000244. Let us take the first example of how to convert a hexadecimal number B41A to its decimal equivalent. Now, the first thing that we need to do is we need to identify the least significant digit, which is A in this hexadecimal number, and the most significant digit, which is B. And before we start solving this, let us keep this table handy, which gives us the equivalence between hexadecimal numbers and decimal numbers. So we know that any symbols from 0 to 9 in hexadecimal have the equivalent value 0 to 9 in decimal, but symbol like A has a decimal value 10, B has an equivalent decimal value 11, and so on, and F has an equivalent decimal value 15. So we will use these equivalent values when we convert this number from hexadecimal to decimal. Now, in this given number, the least significant digit, that is A, has the weight 16 raised to 0. The next digit has the weight 16 raised to 1. What it means is this A will be multiplied with the power 16 raised to 0. 1 will be multiplied with 16 raised to 1. Of course, when we say A will be replaced by its equivalent decimal value 10. And in a similar way, B will be replaced with its equivalent value 11, and that B will be multiplied with 16 raised to 3. So we say that B has the maximum weight here. Now we can write B41A of hexadecimal as equal to B into 16 cube plus 4 into 16 square plus 1 into 16 raised to 1 plus A into 16 raised to 0. So here is a simple way to remember. If we start writing from the least significant digit and move towards the most significant digit, observe A is multiplied with 16 raised to 0. Here 16, this is the radix of our number system that is given to us. This is the radix of the given number system. So starting from the least significant digit, each digit, for example A, is multiplied with an appropriate power of the radix, and we start with the power as 0. So A into 16 raised to 0 plus the next digit is 1, so 1 into 16 raised to 1. And now as we move towards the most significant digit, we keep on multiplying by appropriate powers of 16. So the powers of 16 keep increasing as we go from the least significant digit. As we move towards the most significant digit, you will observe that the powers of 16 keep increasing. Power of 16 is 0, 1, 2, and 3. So this becomes the equivalent value. This can be written as, now using our table, we will substitute. So B we know has the equivalent value 11. So we have B replaced with the decimal value 11 into 16 cube. So that is 4096 plus 4 into 16 square is 256 plus 1 into 16 plus A into 16 raised to 0. Now A we replace it with its equivalent decimal value, that is 10. So 10 into 16 raised to 0 is 1, and this can be simplified into 45,056 plus 1024 plus 16, and plus 10 into 1 is 10. That is equal to 46106 of decimal. And therefore, the given hexadecimal number can be expressed as 46,106 of decimal. Let us take the second example where we convert a mixed hexadecimal number. So this number is CAB.13, and this has an integer part and also a decimal part or a fractional part. We want to convert this into the decimal equivalent. Now the way to do this will be, we first take the integer part and convert it into the decimal equivalent. Then we will take the fractional part and convert it into its decimal equivalent. And once we have the two parts in decimal, we'll just separate them with a decimal point. So let us start with the integer part, CAB. So we convert the integral part CAB to decimal. CAB can be written as C into 16 raised to 2 plus A into 16 raised to 1 plus B into 16 raised to 0. So remember, this B is the least significant digit, and as we move from the least significant digit towards the left, we keep on increasing the power of 16 by 1. So 16 raised to 0, 16 raised to 1, 16 square. And this can be written as, we substitute the equivalent decimal value for C, 12 into 16 square, plus this will become A is replaced by 10 into 16 plus B has the equivalent decimal value 11 into 16 raised to 0. So this can be written as 12 into 256 plus 10 into 16 plus 11 into 1. 16 raised to 0 is 1. And this has the equivalent value of 3243. Now let us come to the fractional part, which is 0.13. This is again in hexadecimal, so we will convert this into the decimal. Now 0.13 can be written as 1 upon 16 plus 3 upon 16 square. Now the logic for this is similar to what we do for decimal number system. So if we had a number in decimal system 0.13, supposing this was a number in decimal, then we know that this could have been written as 1 over 10, because 0.1 can be written as 1 over 10, plus 3 can be written as 3 upon 100, right? So this is the same logic we are using. So if this number 0.13 would have been in the decimal system, we would have divided each digit on the right of the decimal by appropriate power of the base being 10. In this case, the base is 16. So we take each digit 1 and we divide it by the power 16. Then the next digit 3 divided by 16 square. And this can be written as 0.0625. 1 upon 16 is 0.0625 plus 3 upon 16 square is 0.01172, and this, when we calculate, comes to 0.07422. And therefore the given hexadecimal number CAB 0.13 can be expressed as, so we take the integer part 3243, this is our integer part 3243, we separate it with a decimal point and followed by 0.07422. So we have 0.07422, and this becomes our decimal equivalent for CAB 0.13.